Hello everyone, Reactor Labs here, and today in this video brought to you by AEG Test, I'll be showing you guys how well certain materials block a radioactive source. So let's get straight into it. Here I have the AEG Test Radar 5633. This is a energy compensated detector. It actually shows accurate dose rate readings, and this is what I'll be using for our experiments. It also comes with this nice case and all this stuff as well. Pretty cool detector. But now let me show you guys the source I'll be using. So for the source, I have this nice specimen of uraninite from the Mivita mine in a petrified log. This is from Mr. Radioactive Rock. He donated this sample to me. Now, first up, let's just take some readings with the AEG test on contact with the sample. And this is the hotter side. So we place the sample on the back of the detector, right where the semiconductor is. Also, I'll turn off the alarm sound, and then we wait about a minute-ish. I do notice that for more radioactive samples, it doesn't take as long for the detector to update as less radioactive samples, so that's good. So, after waiting a minute or so, I'd say, I'm getting readings of about 58 microsieverts per hour. So, first, we'll start with some materials that I don't think will shield it very well, and then work on to some other materials. Here I have this acrylic, which the only piece of acrylic I have was part of an acrylic case with a rock that I had on display, so I guess I'll just put the detector inside of it like that. Now, also keep in mind that these materials will have different thicknesses, but now I'll place the source right up against the detector, as you can see. After waiting just a little bit and positioning the source where the detector actually is, you can see just this little bit of distance does actually cut down the dose pretty significantly. So we're only at around 30 to 40 microsieverts per hour. Next step for shielding, I have something a little unusual and interesting. This is actually a scintillator. So this is what is in a lot of different types of modern detectors. Technically, this detector, which is by the way only $50 and still measures accurate dose rate, this detector uses something similar to a scintillator. It uses a semiconductor. It's the same general idea as a scintillator, but let's put the scintillator on top of the radioactive source. Now, the thing about scintillators is they are very, very, very dense, so I think this will actually do a fair bit. So, after waiting about a minute and letting it hover, it's at about 20-ish microsieverts per hour. So this scintillator crystal actually does a fair job at shielding radiation. And just to show you guys what this scintillator crystal looks like under a black light, it glows very, very prettily. It's very crazy looking. Next up for shielding, I have this Eisenhower dollar, which is nickel and copper. Let's see how well it shields the radiation. And as you can see, it's kind of thin, so we'll see how well it does, but I'll place it directly over the source like that. Grab the detector and place the detector on top. And after waiting about a minute, as you can see, we're getting about 27 to 30 microsieverts per hour. If you want to shield the radiation coming off of a source, don't use coins. Which, it's kind of funny that I say that, because the next two things that I have to shield radiation are both coins. So, this is a Kennedy half dollar, 1968, about 40% silver, and then this is a 1 troy ounce silver round, so this is pure silver. Now, I'm curious to see which one of these does better at blocking radiation. I'm guessing it's going to be the pure silver round, because it's not only thicker, but also denser, so should be the better radiation shielder right here. Now, I will do the Kennedy half dollar first, just to see. I place it directly on top of the source, and it just about perfectly covers the source, as you can see. That's convenient. And then I grab the detector, and then I place it with the sensitive area directly over the source, and wait about a minute. After waiting about a minute, as you can see, it doesn't actually do too bad. We're getting around 25 to like 28 microsieverts per hour is where I've seen just like that general ballpark. So that's not actually too bad from this thin little coin, although it is quite dense, so that does make sense. Now, next up, what I predicted will be the better radiation shielder, and yes, that is slightly corroded. Oxidized, I'm pretty sure, from where I've touched it previously without gloves. Don't do that. It, as you can see, slightly ruined the appearance of the coin, but yeah, and that very much covers the radioactive source. Now I'll put the detector right on top, and then we wait And wow, as you can see, after about a minute, there is a quite significant decrease in radiation, but it's not actually too different from this coin, the coin that I currently have under there, the silver round, compared to like this coin. They're both actually about the same, although the pure silver round, as I predicted, because it's denser and thicker, does do a slightly better job at blocking the radiation than the Kennedy half dollar I just accidentally dropped on the ground. Don't do that. Now, next up, I have rocks. I actually have 3 rocks that I'm going to be using, but only 2 of them are up right now. But let me go get the 3rd rock. It's absolutely massive. It's huge. As you can see, this piece of shale is humongous. This is massive, but it's also incredibly dense, so I think this will block a ton of the radiation coming off of this source. I mean, it does also help that this isn't an incredibly strong source or anything. First, let's try just this one identified rock. This is just generic, like, metamorphic rock that I found while up in the mountains, and then, as you guys already heard and know, this is nice, huge chunk of shale. Wow, I sound like a nerd. Yeah, just keep in mind that it isn't just the material itself factoring in, it's also the thickness of the material, which is very, very important for radiation shielding. That's why you generally also want distance. But, oh, wow. That's doing a better job than I expected. Well, let's wait a minute and see where it settles out at. Okay, so it's picking up a little bit. It looks like we're starting to actually see some fairly high levels, but that's just about stable. And after waiting, we are getting about 6 microsieverts per hour. That is not very much. So far, it looks like this is the best thing to shield radioactive sources with, except for not really. I don't actually have any, like, lead sheets or anything, so I'll probably post a short or something when I acquire some of those, although I'm gonna have to be careful because lead sketches me out in every way possible. And now this source. Sorry, not source, shielding. As you can see, it's not nearly as thick as this is. It's actually not too far off, but it's also slightly less dense than the iron ore as well, so I don't think this will do as good of a job as this will. Let's see. So, after waiting about a minute, as you can see, as expected, it's getting a little bit more than the other iron ore did, which makes sense. Now, considering the fact that this weighs like, I don't know, half a pound maybe, it's not very heavy, and this beast is not only extremely dense, but also incredibly thick, I think that this is gonna block basically everything. Let's see. Now, because I can't really hold this here, and I don't want to accidentally damage the rock, I will actually be holding it sideways rather than just carrying it. Place the source here, place the detector on the other side, and then report the reading once it's done. So, after waiting only a microsievert per hour through this rock, compared to the source behind this rock, and quite a bit of rock in between and distance and whatnot, versus just having the source and the detector right next to each other. It's actually fairly good shielding material. So, the lesson we learned today is that rocks are really dense and good at blocking radiation. Don't drop silver coins, and make sure if you want to buy the AEG Test Radar 5633 energy compensated radiation detector for only about $50, make sure you use the code and the link in the description. And I will see you guys in the next one. Thanks for watching. Bye.